OAuth 2.0 is an authorization framework, not an authentication protocol. Authentication answers who you are. OAuth answers what you can do. Picture a bouncer checking a VIP wristband rather than grilling you for an ID. The band was issued by someone trusted, and it unlocks specific privileges without proving identity on the spot. Every OAuth flow involves 4 roles working together. The resource owner is the user holding the data. The client is the app that wants access. The authorization server is the trusted token issuing service. And the resource server is the API that guards the actual data. Information flows from owner, through the client, over to the auth server for a token, and finally to the resource server to fetch what's protected. 2 endpoints drive every OAuth interaction. The authorize endpoint is the front door. That's where the user logs in and clicks allow. The token endpoint is the back door. That's where the client trades its short-lived authorization code for a real access token. One door handles consent, the other handles credential exchange. Tokens don't carry identity, they carry scopes. Scopes are granular permissions that say exactly what a client is allowed to do. Instead of handing over a master key, the auth server hands out labeled keys. Read your profile, read your email, write your posts. Limit the scope, limit the damage. Most OAuth flows give you 2 token types. The access token is a short-lived movie ticket, about an hour, used to call the API. The refresh token is a season pass, lasting days or weeks, used only at the token endpoint to mint a new ticket when the old one expires. Short-lived access tokens limit the blast radius if one is ever stolen. OAuth 2.0 ships with several grant types, and choosing the right one matters. Authorization code is the gold standard for server-side web apps. Authorization code with PKCE adds extra protection for SBAs and mobile apps. Client credentials handles machine-to-machine flows where there's no user at all. Implicit is deprecated. Never use it. Resource owner password is discouraged. Don't use it either. Pick the modern, secure defaults and you'll be fine. The authorization code grant is the workhorse of OAuth 2.0, and it works in 6 deliberate steps. The user clicks login, the app redirects to the authorization server with its client ID, the user approves the requested scopes, and the server bounces the browser back with a short-lived authorization code. The app then exchanges that code for an access token in a server-to-server post, and the access token never touches the browser. PKCE, pronounced Pixie, hardens the authorization code flow against interception attacks. The client generates a random secret called a code verifier, sends only its hash, the code challenge, upfront, and proves possession of the original verifier when redeeming the code. Even if an attacker steals the authorization code, they cannot exchange it without the verifier. When no human is involved, machines talk directly. The client credentials grant lets one server authenticate to another using its own client ID and secret, exchanging them for an access token with no user in the loop. This is the right choice for service-to-service APIs, cron jobs, and backend automation. The implicit grant was deprecated because it returned the access token directly in the URL fragment, exposing it to browser history, referrer headers, and any script on the page. The authorization code flow with PKCE replaces it for every modern use case. The resource owner password credentials grant was discouraged because it required the application to handle the user's actual password. Any app that touches a password becomes a high-value target, and most modern apps have no business seeing credentials at all. If you see a password field, the flow is wrong. In practice, most access tokens are JWTs, compact, signed, and self-contained. A JWT is 3 base 64, encoded segments joined by dots, a header declaring the algorithm, a payload carrying the claims, and a cryptographic signature. The payload typically includes the subject, an expiration timestamp, and the granted scopes, and any party with the public key can verify it without calling the server. We will run a live-style terminal session to simulate an OAuth client credentials flow, decode a JSON web token by hand, and probe an authenticated endpoint. Every command you see is real, and its output is exactly what http://bin.org returns. Starting clean with clear, wipes the screen and gives us a tidy workspace. From here, every action will be a deliberate step in our OAuth simulation. This post to http://bin.org/anything mirrors the token endpoint call in a real OAuth client credentials grant. The anything endpoint echoes back our request, so we see the grant_type parameter, client_credentials, parsed and returned as JSON. Next we hit the /bearer endpoint, which is designed to test authorization headers. By default, curl sends no bearer token, and hitbin returns an authenticated response flag confirming that authorization is required to access protected data. Now we crack open a JWT by hand. We echo a sample token, split it on the dot delimiter to grab the middle segment, the payload, and base 64 decode it. The result reveals the claims inside, in this case a subject claim of user 1. We follow that with a head request to OAuth.net to confirm we can talk to real OAuth documentation infrastructure. The I flag fetches only headers, and L follows redirects so we get the final destination's response codes. Finally, /headers shows us exactly what our client is sending. This is invaluable when debugging auth flows because you can confirm the authorization header is present and correctly formatted before the server rejects the request.